Good day, class. This is Sir Kenny with another topic for STM006 or General Chemistry 2. Today we will talk about module number 18, which is about writing the reaction quotient and the equilibrium constant expression. So before we begin, let us have our lesson objectives. So by the end of this lesson, you can say that yes, I can calculate the reaction quotient and I can write the equilibrium constant expression on different reactions. Now, before we delve into our main topic, let us have our definition of terms. Unahin natin si kinetics. Kapag sinabi natin kinetics, it addresses the speed of a reaction, the change in the product concentration or reactant concentration per unit time. Kapag sinabi kasi natin na kinetics, ito yung movement ng mga particles from the reactants towards the products or from the products towards the reactants. Because we are referring to reversible reactions, kapag sinabi natin reversible reactions, ito yung may mga arrow sign na bidirectional. So, nakalagay dito na product concentration or reactant concentration. This is because in a reversible reaction, yung ating mga reactants, they form the products and in turn, they produce the reactants. Now, let's go to equilibrium. When we speak of equilibrium, it addresses the extent of a reaction, the concentration of product that results given a limited reaction time. Kasi kapag sinabi natin equilibrium, ito yung balance between the amount of reactants and products. So, kapag sa umpisa pa lang, panay-reactants pa lang yung ating mga substances, they will undergo chemical reaction to produce the products. Okay? Now, since the reaction is reversible, some of the products will be reverted back into the reactants. Kapag sinabi natin equilibrium, pantay na yung ating amount ng reactants at ng products. So, at equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. Okay? So, when we speak of forward reaction from reactant to product, pag sinabi naman natin na reverse reaction, ito yung from product to reactant. Ngayon naman, itong reaction na ito, hindi ibig sabihin na kapag naging equal na yung amount ng reactant at ng product, ang mag-i-stop na ang chemical reaction. At the molecular level, the system at equilibrium is said to be dynamic. Ibig sabihin, gumagalaw pa rin siya, kumikilos pa rin siya. Kumikilos siya in the sense na if the reactants produce the product and the product produce the reactants, hindi siya mag-i-stop kapag naging equal na ang kanilang amount. Ang nangyayari ay, habang nagkakaroon ng reaction from reactants to form the products, ay nagkakaroon din ng reaction from product towards the reactants. Ang nangyayari dyan is, there is no net change. Ibig sabihin, walang sumobra or walang bumawas doon sa total amount ng reactant at ng product kapag ang ating system ay nasa equilibrium. Ibig sabihin, dire-diretso na nagkakaroon ng chemical reaction from reactant to product and from product to reactant. So, if the rate of the forward reaction is equal to the rate of the reverse reaction, then we can say that the reaction rate constant, which is the K, or sometimes it is referred to as the reaction rate coefficient of a forward reaction, is equal to the reaction rate constant. Again, it is the K, or sometimes it is referred to as the reaction rate coefficient of the reverse reaction or the products. Our reaction rate constant in an equilibrium is equal to the K forward over K reverse. Or we can write this down as the K forward or the product concentration over the reactant concentration. So, kapag sinabi kasi natin na forward, it is from the reactant towards the product. So, sa ibabaw or sa ating numerator ang ating product. Pag sinabi naman natin na reverse, it is from product to reactant. So, the reverse is denominator natin na reactant. So, this is also known as the law of mass action. Now, before we begin, let us always balance the chemical reaction. In order to balance this, naglagay tayo ng 2 sa coefficient ng SO2 and 2 sa coefficient ng sulfur trioxide. So, our reaction rate constant or the reaction rate coefficient, C stands for the concentration. Now, our concentration is always in molar concentration. So, naka-mole over liter siya, or simply put, molar concentration. So, K forward over K reverse. The K forward, or the product, is SO3. So, we can write it down as SO3. Next, kung ano yung coefficient ng ating mga substances, yun yung kanilang magiging exponent. So, for SO3, ang coefficient niya ay 2, so ang exponent niya ay 2. Next, over the reverse, which is the reactant. So, sa reactant, dalawa, so SO2. Tapos yung coefficient ng SO2, which is 2, multiplied by oxygen. So, si oxygen ay 1. Walang coefficient, kaya considered as 1. So, hindi na natin kailangang sulatan ng 1 na coefficient. Now, at a specific temperature, kapag pinlug in natin lahat ng values ng ating reaction rate constant, it will be equal to 4.3. Now, this is at equilibrium. Paano kapag wala pa sa equilibrium yung ating substances? Or paiba-iba sila ng amount ng concentration? So, dyan napapasok yung ating reaction quotient. Now, this is for the concentration of the reaction rate constant. Ngayon naman, paano naman yung ating reaction quotient? So, remember, K is for constant, Q, on the other hand, is for quotient. So, our concentration, so in order for us to write down the reaction quotient, it will be the K forward over the K reverse. So, this will be equal to SO3, which is a product. Kung ano ulit yung coefficient, siya yung magiging exponent, over the reactants, which is SO2. The coefficient of SO2 is 2, so it will be also its coefficient, and then oxygen. Okay. So, anong pinagkaiba ng dalawa? Pareho naman sila na K forward over K reverse. Ang pinagkaiba nila is, for Kc, K stands for the constant or the reaction rate constant, and C stands for the concentration. Ito yung kung saan nasa equilibrium na ang ating reaction or yung ating mga substances. Whereas for Q, which is the reaction quotient, ito yung wala pa sa equilibrium. So, ibig sabihin, there will be changes or there will be differences between the values na makukuha natin sa ating reaction rate constant at sa ating reaction quotient. Now, for example, the concentration of our substances are as follows. So, for SO2, our molar concentration is 0.1 molar. For our oxygen, our concentration is 0.3 molar concentration. And then for our SO3, our concentration is 3.5 molar concentration. Now, given ng ating reaction rate constant, what we have to find out now is the reaction quotient. So, by substituting the values, SO3 is 3.5. So, 3.5 molar concentration squared over SO2, which is 0.1 molar concentration. Do not forget the exponent. And then, oxygen, which is 0.3 molar concentration. Now, since this is division, ang mangyayari niyan ay makakancel yung ating units. So, the molar concentration will become cancelled. So, our answer will have no unit. So, by using our calculator, it will be 3.5 raised to the second power divided by 0.1 raised to the second power times 0.3. So this will be equal to 4083.3. So 4083.3. So we can see the difference between our reaction rate constant and our reaction quotient. Now there are three possibilities. So it could either be K is equal to QC. So ibig sabihin na kung ang ating reaction rate constant, which is K, is equal to our reaction quotient, which is QC, ibig sabihin our reaction is at equilibrium. The other two are if KC is greater than QC, or if KC is lesser than QC, which is our example here, na mas mataas si QC as compared to kay KC. So in order for us to better understand this, gumawa tayo ng number line dito. Now our point of reference is the QC. So dito sa ating arrow, pwede tayong maglagay ng iba-ibang values. Pwede tayong maglagay ng 0 dito, tapos sa last one ay infinity. Kapag ang ating QC is 0, ibig sabihin, it is all reactant, walang product. Dito sa ating formula kasi, it is K forward or the product over K reverse. Now, if our QC is at 0, ibig sabihin, wala tayong numerator, wala tayong forward reaction. So, ibig sabihin, at this point, all of our substances are reactants. As we go towards infinity, mas kumokonti na yung reactant natin kasi they are undergoing chemical reaction, so mas dumadami ang product. So at infinity, it is all product. Now we can input values within this arrow. Yung ating values, nakadepende yan sa ating mga nakuhang value sa ating KC at sa QC. Dahil yung value na nakuha natin ay sobrang magkalayo, ang gagawin natin ay we are going to write down here 1,000, 2,000, 3,000, and then 4,000. Our KC is 4.3. So nandito si KC. Si QC naman natin nasa 4,083. So, nandito siya. So, QC. Now, since QC is our point of reference, what will happen is QC will adjust to go towards KC. Ibig sabihin, what will happen to the reaction? Will it be going from reactants towards the product or from product towards the reactant? QC is our point of reference dahil siya yung graph natin, then therefore, si QC ang mag-a-adjust. So, si QC, mag-move siya towards KC. So, ibig sabihin, mas marami siyang product. So, because the reaction will try to attain equilibrium, susubukan niyang pantayin ang amount ng reactant at ng product. Yung mas maraming amount ng product ay mag-a-adjust to form reactants. So, ang reaction natin ay towards the reactants. So, yun yung ibig sabihin ng ating graph. So, let us remember, if KC is equal to QC, then that means the reaction is already at equilibrium. Now, in this case, si KC ay mas mababa compared kay QC. So, nandito tayo. So, if this is the case, then the reaction will favor the reactants. Ibig sabihin, papunta yung ating reaction, papunta sa reactants. Kapag si KC naman ay mas mataas kay QC, so ibig sabihin, in this case, ang reaction natin will favor towards the product. So, reaction will favor the product. Ibig sabihin, yung reaction natin ay papunta mula sa reactant papunta sa product. Let us have another example. Now, the first step is to always balance the chemical equation. In this case, ang ating bilang ng carbon, oxygen, and hydrogen ay equal. So, there's no need for us to balance the chemical equation. Next, let us substitute the values. K forward is our product. So, it will be CO2 and H2 Next, our denominator. Remember, this is multiplication, hindi po sila addition. Di po may plus dito, ang ating maging formula ay addition, hindi po. Lahat po ay multiplication and division lang dito. Next, our reactant, which is CO. And H2O. Now, in this case, wala tayong mga exponent kasi yung ating mga coefficient nung binalance natin yung chemical equation ay 1. So, that means wala rin silang coefficient. So, at a certain temperature, ang ating equilibrium constant daw ay nasa 1. As stated here. Next is we have to identify our value for the reaction quotient. So, QC is equal to, same lang po sila, CO2H over CO and H2O. Next, substitute the values. For CO2, it is 2 molar concentration. For our hydrogen, it is 2 molar concentration over CO, which is 1 molar concentration, and for our water, it is 1 molar concentration. Now, this will be equal to 4. Bakit 4? Kasi 2 times 2 is 4, divided by 1. So, our value for our reaction quotient is 4. Now, ano ang ibig sabihin yan? Remember our graph again? So, our point of reference is QC, or the reaction quotient. This is 0, this is infinity. Now, since ang value natin ay maliliit lang, 1 and 4, we can write it down as 1, 2, 3, 4. Next, our KC is at 1. So, nandito yung ating KC. Ang ating QC ay 4. So, QC. So, what will happen? So, since QC as our point of reference, siya ang mag-adjust, siya ang mag-move. So, QC, remember, so QC will move towards the KC. So, nag-move siya papunta sa left. Remember that papunta sa left, ang QC natin ay 0. So, ibig sabihin nito, this is all reactant. And doon sa infinity, it is all product. So, since nag-move ang QC natin from 4, papunta siya sa KC, which is 1, nag-move siya to the left. So, ibig sabihin, the chemical reaction will favor the reactant. So, this will favor reactants. So, ibig sabihin, mas maraming product kaysa sa reactant. So, in order to achieve equilibrium, the products will reverse its reaction papunta sa reactant. So, this reaction will favor the reactants. I would just like to add na dito sa ating reaction quotient, this is only applicable to substances which are in gaseous form or in an aqueous solution. Ibig sabihin nakadissolve sa water. Hindi siya applicable sa mga substances na nasa liquid form or nasa solid form dahil ang kanilang composition ay constant. Ibig sabihin uniform or hindi nababago ang kanilang composition. So that's it for module number 18.